All right, in this second video of the Maths of 1.3, we're going to go over the midpoint formula and then just a couple of vocabulary words there. So whenever you see the words midpoint and segment bisector, one thing to do is to kind of think to yourself that these are two equal pieces. So just think two equal pieces. To basically cut it in half. So a midpoint, it has to do with a point that divides a segment into two congruent segments. And a segment bisector is a ray, a line, a plane that intersects also a segment at the midpoint. So it's cutting it in half. An example of that is, for example, right here, point M. We have point M in the middle is the midpoint between V and W, segment V and W. Find the length of VM, which is this part, and VW, which is the whole thing. So if they're telling you that this is a midpoint, you are to assume that these two parts are equal, and they, again, are shown with that little dash right there, that they're equal, which means that if we take the algebra out of that, we're going to write that 4x minus 1 equals 3x plus 3. This is just an equation like in algebra, so we're just going to solve for x. We're going to subtract 3x from both sides. So 1x minus 1 equals 3. Now we're going to add 1 to both sides. 1x equals 4. So x equals 4. So to find Vm, the length of Vm, we now need to look at the expression represented by that. So Vm equals 4x minus 1, which means we're going to now replace the x in there with the 4. And then 4 times 4 is 16. 16 minus 1 is 15. So the length of VM equals 15. Then we're going to do VW. VW is the whole thing. And this is where you can plug in the 4 in there also in that expression and then add the two answers. Or logically, we can assume that because they are equal, this space right here is going to be 15. And this space right here is going to be 15. So the whole thing is going to be 30. So you don't have to do algebra all the time. You just have to reason your way to the answer. So that takes care of answering those two. So that's the example with the segment bisector. Now with the midpoint formula, we're looking at 2 points that could be plotted anywhere. And you're finding that middle point right there. What is the x and the y coordinate for that midpoint? So a couple of things here is that if you're visual, you can always use the grid to plot that. But if you just want to follow the formula, this is the formula. It's telling you to look at your x's. So this is like a big giant point right there for the midpoint. To get the x value for that midpoint, we need to find the average. The average of the x's and then the average of the y's. And whenever we do an average, we basically just add what we have and then divide by however many things we have. In this case, you have 2 x's, so we're going to add the x's that we have, and then we divide by 2. So that's the average of the x's. Here we have the y's. We're going to add the 2 y's and then divide by 2, so that's the average of the y's. And these two create that midpoint. It just mathematically works out that way. So, for example, if we want to graph here, what are the coordinates of M? The midpoint of segment RT are these 2 points. So we're going to do -2, -3, that's R. And then we're going to do 6, 2, 4, 6, and then -10. So we're going to do 2, 4, 6, 8, 10. So all the way down here. T. So in between this, there is a midpoint somewhere here, and we're going to label it M. So to find that midpoint and exactly where it is, we don't just kind of stare at it and figure it out. We actually calculate it mathematically with the formula. So we're going to find the x's, -2 plus 6, and then divide those by 2. That's going to give you your x value for the midpoint. Then we're going to do the y's, -3 plus -10. divided by 2. That's going to give you the y value of your midpoint. So we can use the calculator or use our head. Negative 2 plus 6 is positive 4. 4 divided by 2 is a 2. Negative 3 plus negative 10, that is negative 13. Divided by 2, that will be negative 6.5. So here it's saying that we're going to plot 2 and then 2, 4, 6.5. That's where the M is at. And that will be the midpoint for those two. Let's try it again. So now we have the coordinate G. Find the coordinate of G. So if E is negative 1.5, I'm sorry, negative 1 comma 5. So negative 1 and then 2, 4, 5. That is E. And it is the midpoint of GH. So E is the midpoint of GH. H is 5, 8. So 1, 2, 3, 4, 5, and then 2, 4, 6, 8. This is H. So here, they're not giving you the points to find the midpoint between that. They're giving you the midpoint to find the other one. Here, there's several things we can do. Some of those students that are visual with the whole rise over run could remember that you could drop a certain amount of units and then move to the left or right a certain amount of units, and then just follow that pattern to continue finding points along the line. So that's one way that we can do this. But just keep in mind that we're missing that endpoint. You can also kind of like think of the values that you have. You have negative 1, comma 5 for E, and then you have 5, comma 8 for H, and you're looking for another point over here, and that would be G. So you could kind of leapfrog your way as well, jumping. So from 5 to negative 1, how many spaces were there? So from 5 to negative 1, there was 6 spaces. So if you go again 6 more spaces, you will go all the way to negative 7. Because on the X values, you're going 6 spaces. On the Y values, we went from 8 to 5. So from 8 to 5, you subtract 3. From 8 to 5, we subtracted 3. So if we go another 3, we're going to end up at 2. So that's another way to visualize how these are changing. So there's that. And then like I said, there's the rise over run. You drop 3 and you move 1, 2, 3, 4, 5, 6. So then you're going to drop 3 again. And then you go 1, 2, 3, 4, 5, 6. And that is how you can find that negative 7, 2, 2, 4, 6, 7, and 2. So that's your G. So the answer for G will be negative 7, 2. There's just many ways to get to it. And again, it's through reasoning and based on your foundation of understanding math. All right, one last thing I want to show here is on a number line, point A is negative 7 and point B is 11. So sketch that. You have a point A at negative 7, and then you have a point B somewhere over here at 11. Find point C on segment AB, that is 1/3 the distance from AB. So here we need to kind of look at what we have and think of thirds. How could we find 1/3? Another thing we can do is just find what is the distance that we have right now. So from negative 7 to 11, there's a 0 somewhere here. So that's 7 spaces, and then that's 11 spaces. So a total of 18 spaces. So if the whole thing is 18 and you divide that into thirds, that's like saying you're dividing 18 by 3. So the distance will be 6. Now, 1/3 of the distance between A and B is 6. So 1/3 of the distance that you currently have, it's like saying 1/3 of 18 equals 6. That's how you get that answer. Then it says that would be us counting 6 spaces. 1, 2, 3, 4, 5, 6. So somewhere here. And that's at point C. And that's -1. And this is 0. So C is right here. And then find point D on segment AB. That is 3/4 the distance from AB. So on this one, we're going to still look at 18th. And we're going to find the fourths and then the 3 of those fourths. Or we can just say we want to find 3/4 of 18. We can see it as multiplying 3 times 18 divided by 4. This results in 13.5. So 3/4 of 18 is moving 13.5 spaces. So we're going to go from -7, 13.5 spaces to the right. So from here to here, this is 7 spaces. And we're going to go in total 13.5. So if you subtract 7 here, you already have 6.5 left. So we're going to go 6.5 spaces to the right. And this is going to be point D. And it's going to stop at 6.5. So try, again, pausing, rewinding, or rewatching this video if you need a more visual, again, of how to do this. Hope this video helps you.